Are you a front-end developer who has always wondered how the world of Web3 and blockchain actually works? Have you seen those high-paying blockchain front-end developer roles and thought, I wish I knew what that was about? Well, today is your lucky day. Welcome to this comprehensive tutorial on building blockchain-connected React apps with WAGMI. I'm going to be showing you how to exactly bridge the gap between traditional React development and the lucrative world of Web3. And yes, the prerequisites are simple. You just need to understand concepts like the React hooks, components, state management, and basic async JavaScript. You do not need any blockchain experience. We'll be building a complete dApp, that is, a decentralized application that connects to various Web3 wallets like MetaMask. We'll be reading blockchain data like token balances and executing real crypto transactions. Here's why this matters. The Web3 frontend developers are in massive demand and short supply. Companies are paying premium salaries for developers who can build user-friendly blockchain interfaces. Think the likes of Uniswap, OpenSea, and Aave. The best part, your React knowledge transfers directly. You're not just learning concepts like the traditional HTTP GET put, but you're learning new API concepts. It's like calling different endpoints, except these endpoints are smart contracts on the blockchain. And yes, understanding the Web3 concepts like the EVM and other smart contract terminologies makes you a React developer that stands out. This demo app that you can see on the screen will also be on GitHub. And by the end of this tutorial, you will understand exactly how blockchain front-end applications work on that hood. That being said, let's dive straight into coding. This is the sample of what we'll be building. This is a front-end Web3 React app. And basically, just like I stated here, the tutorial demonstrates how to use WAGMI hook to interact with the Ethereum blockchain. This tutorial is perfect for React developers that are ready to dive into the world of Web3 development. So the functionalities that we'll be considering actually are the first thing is how to connect a wallet to your application, right? So the first thing, when a user gets into a application, a web app, we want to actually connect their wallet, because it is through the wallet that transactions can be signed from the blockchain, especially when you want to write to the blockchain. Do not worry, all this data here are still dummy data. We're still going to go into the real implementations. So a user will be able to like connect their wallet, and upon connecting, you don't just want them to be stuck forever on your website, right? You also want them to have the functionality, the ability to disconnect from the platform. We would also learn how to read a wallet balance. So this as a dummy data, like I said, this wallet I just put in this value of 1.234 ETH. Then we'll be able to like navigate across various networks on the EVM chain. I'm going to do a quick introduction for developers who do not have an idea about the blockchain at all, just after this explanation. So we have quite a number of chains. We're able to like switch from Optimism to the Ethereum mainnet to Polygon or Avalanche. Then also for the connected address, we'll be able to see the recent transactions that the address has carried out. Even by checking maybe if they've sent tokens or they've sent native coins such as ETH. And I'm going to explain all of that to the difference between a token and a coin. The difference is subtle, but the difference does exist. Then also we're able to read contracts data using WAGMI hooks. In the earlier explanation or introductory section, I said that WAGMI, we're using WAGMI under the hook. Under the hood, I mean to say to actually access the Ethereum blockchain. Then also be able to read contract data also. Then the right to contracts is, in this particular example, be able to send tokens to your recipient to an address, right? And we'll specify the amount of tokens I want to send. And this is the code example. All these are dummy data. So basically, tutorial would span how to actually install WAGMI, fetch and read contract data, and also how to write transactions and other error handling methods that you'd use. So in a case whereby a user tries to send a token and they do not have enough balance, we want to actually show them an error. So Those are actually proper error handling methods that are very, very useful. So this is the code base, and this is everything that will be implemented in this tutorial so far. So if you are actually very good with it, or you know that you understand everything, you can proceed to actually fork the repo on GitHub. So for developers who do not even have an idea about the blockchain or the different type of blockchain networks that we have, let's start with this simple example. If you've never touched the blockchain before, think of it like this. Let's say you have a traditional application. When I talk about traditional application, I mean applications that people are much more familiar with, that people use day in, day out. So let's say you're the React developer for this particular application. Your React app calls, let's say an endpoint called api.mycompany.com/users. You know that's the data on that API or on that endpoint lives on your company's server. So your company controls the database, and users must trust your company to handle their data correctly. But with blockchain applications, your React app calls a blockchain network instead of an endpoint, right? So your React app would be calling a blockchain network, and the data lives on thousands of computers worldwide, and that this is the difference with the blockchain. So no single entity controls the data, and also users can verify everything independently. So a blockchain is an interconnected network of nodes that actually passes data. Basically, that is just a simple illustration. Like a real world analogy, instead of keeping your bank records in one bank database, imagine if every transaction was now recorded in thousands of identical ledgers held by people worldwide. So, blockchain or decentralization is necessarily giving power back to the people. And also, we have different blockchain networks, and each network has its own advantage. But basically, in this tutorial, we'll be dwelling more on EVMs. I do not really want to go into the rabbit hole of blockchain networks, but EVM chains are chains that are compatible on the Ethereum network, and we have the likes of Polygon, Avalanche, and do not worry, as you explore more into the world of blockchain, you're going to understand how the EVM works. You're going to understand concept like Turing completeness, if I'm correct, and there's a whole lot of things. But for today, let's just dive into how to the basics that I showed on that particular website, right? How to connect a wallet, disconnect, read data from a balance, see all the transactions that an address has carried out, and how to actually send transaction. So this is basically an introduction of how the blockchain works for developers that do not have an idea about the blockchain at all. The first step in getting started, our first step will be to install WAGMI. Now, to install WAGMI, you simply have to go to wagmi.sh. Then, because we'll be using React for this project, right, next year, so you can simply click on React. Then the documentation always is go-to way to simply understand everything that as developers, we always have to like check through the documentation. So the first step is to actually install WAGMI. Now, personally, for this project, I would be using NPM. So if you're using PNPM, Yarn, just go with what the package installer that you're using on your laptop. So because I use NPM, I'm going to install WAGMI, also Vim, and TanStack query. So just like the documentation says, Vim is a TypeScript interface for Ethereum that performs blockchain operations, and TanStack query is an async state manager. So it handles requests, caching, and also if you're a developer that is even familiar with TanStack query on the side, you know that people use it for to manage API request and also caching. You get then TypeScript is optional but highly recommended. But although in this our tutorial, I'm using JavaScript. So the first step is actually to install WAGMI. And to do that, to simply open our terminal, right? And we can paste it npm install. So while we are having WAGMI installed and TanStack query with Vim, we can also still check through the documentation for the next step. So in getting started, we see that WAGMI is a React hook library for Ethereum, right? So WAGMI is a very, very powerful React library hook for Ethereum. And just like how we have some installed or pre-built Ethereum hooks like the use state, use effect, use ref, and all of that, use memo, WAGMI also comes with quite a number of hooks. And as you can see on this left-hand side, we have the use account effect, use balance, use block, use call, use chain ID. And a lot. So WAGMI is a React hook library for Ethereum. It makes interacting with the blockchain, with EVM blockchain, very, very, very simple and modular. So the next step would be going through is to create our config. Right now, we're instructed to create and export a new WAGMI config using this create config. So what we can do is copy this code, right? Then we head back to our code base. So to do that, I personally create a config folder. Then I can actually just call it WAGMI config. Yep, so we're good to go. With this, we've actually configured WAGMI to, we're not done, but just like we're instructed, so we've actually gotten the WAGMI config, and this is what we'll be using for our app. So let me just break this down. So we see that we're importing create config from WAGMI, and we're also importing mainnet and Sepolia from WAGMI chains, WAGMI/chains. Now, this installation process is not done. I don't know why it's taking time, but um, with the create config, all of these methods are under the WAGMI hook. I mean, WAGMI itself, I mean to say. So the create config is a function that helps us to set up our entire WAGMI configuration, this create config. Then the HTTP method is a transport method. You know, we have HTTP, we have HTTPS, but the HTTP method is transport method on how our app will be talking to the blockchain. And we also have this that you see here are called chains. So we have quite a number of them. We have mainnet, we have Sepolia, we have the BSC, Binance Smart Chain. We also have Polygon, Arbitrum, and all of that stuff. So the create config here, like we see here, the function is how we wrap our entire WAGMI configuration, right? Now, one other thing that I want us to pay attention here is this transport. The transport. So the transport is how our React app communicates with each blockchain. Now, it's important to know that the blockchain, we spoke about different blockchain networks. I wish this installation was done. Okay, so let's say I'm importing Avalanche to from this. Now, Avalanche is a chain that differs from Sepolia, and it's a chain that differs from mainnet. So the transport is the way that our app communicates with different blockchains. While all these chains, both Sepolia, Avalanche, are EVM compatible, the transport is how our app communicates with each blockchain. So because this is quite a number of blockchain, as you can see, this is 3. So we use this HTTP to request to communicate with blockchain nodes. So blockchain nodes are computers that are actually running on this is my Copilot suggesting that. So with this step, we've simply imported the create config for our WAGMI, because this will help our app to access all the functionalities that WAGMI gives us. So the next step would be to, following the documentation, the next step would be to wrap our app in a context provider. So the next step is to import WAGMI into our layout.jsx, right? So we import WAGMI provider. Now we have to change the config, right? The config that we have here is not what I named mine. I named mine as WAGMI config, right? So I can do import WAGMI config from. So I have my WAGMI config in my config folder, right? So I can do the route config/WAGMI config. Yeah. The next step is to wrap the entirety of the app under WAGMI provider. So I can do WAGMI provider, put the body, I next the body under WAGMI provider, right, as a child under WAGMI provider. Then the next step also from the documentation is to set up TAN-stack query. So I can import query client. I'll import query client and import query client provider from TAN-stack/React query. So we can copy this, go back at the top, import query client. So the next step, what we have to do after doing this, we have to create a instance of the query client, right? So we can do const query client const query client is equals to new query client. Then we also now have to wrap the query client provider under the WAGMI provider as a nested child, right? So we pass the body in between the query client provider. Now with this, our app is fully wrapped around WAGMI. Also, the config here has to be changed. Yes, because the config, I have WAGMI config. Mine is not config. I named it as WAGMI config. So I can also wrap it in curly braces. So with this implementation, our app is fully set up to use WAGMI, right? So the next step from documentation is to use WAGMI. Okay. Oh, we're getting an error. Oops. Function cannot be passed down directly to client component unless you really expose it by making it use. So what we can do is, let's go back to our layer.jsx. And at the very top, let's use the keyword use client. This is the word use client. This should solve the error. Okay. Just reload. You are attempting to export metadata from a component marked with use client. So let's just, I think I will just comment out the metadata. I can actually import it externally. I'll do that. I'll attend to it later. So let's refresh. Error should be gone. Okay. Now that our website is without bugs, now that it is free, this data that you can see here are dummy data, right? So I actually coded this so we can have an idea of what you'll be able to do or the things you'll be able to do. Now, when a user comes to our website, they need a wallet to do things, to sign transactions on the blockchain, right? Although when you want to read data, you don't need a wallet connected, but to do things, you need a wallet to do those things, right? So this data here, all this data you can see from the balance, the dummy data. If you come to our yes, these are dummy data. Everything is dummy data. But if we go to our mock page, right? If you check the components imported at the top, if we go to the balance display, let's check the hooks, the WAGMI mock hooks that I just created, the dummy data. If you look at the use balance, you can see formatted to be 1.234 and symbol ETH. If you go back to our website, you can see that the wallet balance here reflecting is 1.2342, right? So these are just dummy data. All these components in the mocks are dummy data. So it can give us a feel of what we'll be building. So let's go back to our page.jsx. Now, if we remove this mock page and we use React fragments, and I do div welcome to real implementation. Oh, pardon my spelling. Implementation. Okay, so we have this saved. If we should reload the website, we should just say blank screen. A blank screen. Welcome to real implementation. So, okay, that works. So, while we have this, we want to be sure that our app is successfully able to use WAGMI, right? We want to be sure because when the user comes to our website, they need to do things. So, React comes with quite a number of hooks like the use state, the use effect, the use memo, use ref, and all of that stuff. WAGMI itself, if you check the documentation, comes with a whole lot of hooks that makes EVM very easy to use. So we have the user account, the use balance, the use chain ID, and also if you check the user account, as it says, it's an hook for getting the correct account. So to do it, you import user account from WAGMI to use it, right? Then if you scroll to the bottom, you see addresses, the chain ID, connector, status, and all of that stuff, like quite a number of things. Then also the use connect, there's another hook that you can use to connect to a wallet, to different wallets, right? Now let's go back to the user account. Let's import the user account in our page.jsx. Let's do import use account from WAGMI because it's a hook from WAGMI, right? If it's React, you do import use state from React, but we're using it from WAGMI. So we can now do destructure the user account. We can do const is connected to check if the user is connected to our app. No, let me just call the user account first. So I'll do user account and I'll call it. Then I can now destructure is connected. You can see that it suggests it. So now I have the structured is connected from user account. What I can do now is to check if a user is connected. And one approach that I can use is to log. I can do console.log CLG. That's the shorthand CLG, and I'll do is connected, right? So if I go to our website, I'm getting an error. Attempt to call user account from server. So let's just call use client at the very top. Let's use client keyword. Then if you do use client, then we go back to our website, right? And we inspect it. We should see the status. So it is false. Is connected is false, right? So it means that no user is currently connected to our application. So this successfully shows us that WAGMI is successfully wrapped totally around our app. So the next step would be to connect a wallet to our app. That's very, very important. And it's like authentication in normal traditional website. Like people have to log in to want to connect wallet. So let me just put in the temporary data back, the mock page. Let's go back to our website. So this is the UI that we still want to follow. This was built with Tailwind. If you know Tailwind, if you can walk around Tailwind, you know how to like just modify the UI design. So now that we've confirmed that WAGMI is successfully wrapped around our app, I think our app can successfully use WAGMI. Now the next step would be to implement the connect wallet functionality on our app. So we can easily head back to wagmi.sh, right, and go to connect wallet. So the ability for users to connect their wallet is a core function for any dApp. It allows users to perform tasks such as writing to contract, signing message, or sending transactions. And there are a lot of third-party apps that you can use to do this, like the Connect Kit, the App Kit, Rainbow Kit, the Dynamic, and Privy. We can build our own. So for this particular step, I would want us to build our own. We'll then move on to maybe use a third party. So in building your own, it says that documentation says that WAGMI provides you with the hooks to get started building your own connect wallet module. So what we have to do is that we have to head back to our config and actually import the WAGMI connectors. So there are quite a number of them. We have the injected, we have MetaMask, we have Safe, and we have WalletConnect. So for developers who do not have idea about Web3, wallets are the means to which a user can carry out functions. You necessarily will need a wallet to do things on the blockchain. So these connectors are different types of wallet providers. Let me use that word. So we have WalletConnect. WalletConnect is a wallet provider. We have Safe. We have MetaMask. MetaMask is very common. Then we also have the injected. Anywhere you see the injected wallets are wallets that are actually injected on the browser. So there are some browsers like the Brave browser that I'm using. It has its own wallet, right? So let's say on the website, the user has MetaMask installed, right? MetaMask would be seen as an injected wallet. That is a wallet that is injected on the browser. So to use WalletConnect, we need a project ID. So let's just move on. So what we need to do in our config, we have to import WAGMI connectors, right? So we can easily go back to our config and import WAGMI connectors, right? But I would not be using WalletConnect for now because we would need a project ID, and I will show you how to get that. So after this, we simply need to pass in the connectors in the create config, right? So yeah, we can just pass in the connectors. So what this means is that we're telling our configuration, our WAGMI configuration, to work with injected wallets in the browser, WalletConnect. We're not using this at the moment. Let me just click it out. With MetaMask and Safe. So all of these are actually wallet providers, right? So with this, we have this done. So what does the documentation says? It's the same wrap your app in. So we necessarily do not need to do this. What we now have to do is now instantiate a connection. So we need to display our wallet options. So let's head back to our page.jsx. If you remember, this page.jss, I've pasted everything that is in the mock page here. So I just copied everything in the div and I pasted it in the page.jss. You know, normally what we had was the mock page. So I just removed the mock page component and I pasted everything in the mock page itself. That is the div from start to bottom. I copied it, I took it and I pasted it right here. So now for our website, the first thing we want to do, we're having connector fn is not a function. So let's check that. Okay, so the error is gone. Code can be funny. So what we want to do is we want to ensure that a user can successfully connect their wallet to our app or dApp, right? So, these are dummy data, right? This data here on the connect page is what you see on this wallet connection on the mock, right? So this wallet connection, user address, all of these are dummy data from WAGMI mocks, right? So we want to now use real implementation. That is when a user comes to the app, the user automatically will not be connected, right? What the user wants to see is a list of options to connect their wallet, right? So let's let's use a sample website. Let's say we go to, okay, this is a sample Web3 project. Let's say exactly on this website that you can see, we see that the first thing is to connect their wallet. Then we see a pop-up modal, right? So get started also is like connect your wallet to do something. So that's what we want users to see too. We don't just want to see them, they don't want to be connected if they've not connected before. So the first thing that users want to see is a list of wallet options, right? So we have to pass those wallet options. That is the wallet that we stated in our connectors. We want to pass them as wallet option. So how do we go around that? So now we have to tweak this wallet, this wallet connection here. What we can do is, since all of these are mock data, I can simply copy this, right? Copy all of this and create components. I don't want to tamper with what is in the mock, and I'll call it wallet connection. Wallet connection .gsx. Right, I'll just paste everything here. So in my page.jsx here, I do not want to import the wallet connection from mocks. I want to import the wallet connection that I just created in the components folder, right? I can just do /components /wallet connection. So we'll still have the same thing, but I just want to start tweaking the data to match what we have. Cannot resolve WAGMI. Okay. Oh, I think now I'm now getting an error from this my imports here. So this would change, right? So it's be // mocks / WAGMI mocks. So that way it is. Okay. So it's in WAGMI mocks, right? So this would resolve the error. So I want to change all this data here. I want to change this data here to real data. So I want to start using Ethereum implementation. So what we can do is we can console.log this out. We can console.log this out, and we can now do import. Now, to get an address, everything like you see from the mocks, to get the address that is connected, we have to get it from the user account. So we can do import user account from WAGMI. That's the first thing. We're using real implementations now. Then we also have to connect the wallet, we have to import the use connect hook. So if you simply over it, it tells you that you use connect blah 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 blah. So to connect the wallet, then to disconnect also, we have a disconnect button. We have to import the use disconnect. And all of this, I'm not just saying it out like as if I'm performing magic. No, it's right there in the WAGMI hooks documentation. So if you see the use disconnect, it tells you that hook for disconnecting connections, the use connect, hooks for connecting with account connectors, blah blah blah. So now, are you saying that automatically in our website, we're already seeing the injected wallets because we're already using real implementation? Remember that in our config, in our code, right? In our config, in our code, what do we have in our WAGMI config? We have the injected, we have MetaMask, and we have safe. So why you're seeing that list is because why you're seeing all of this here is because we've configured it um, in our WAGMI config. So why you're seeing Brave is because Brave Wallet is imported here. So when we say connect injected, in most time browsers read it as MetaMask, right? And you might be wondering how did the wallet just show up, like the list of wallets? So I'm going to explain because the setup was already done from the WAGMI mocks. So to know the available wallets, we are going to destructure the use connect. So let me just let me comment this out and let's work alongside. So to connect wallets, we have to do const. We can do const is equals to use connect. We'll call it, then we can now start destructuring. So this connect itself is the function that connects us to a wallet. Now, the connectors are the series of wallets or the series of wallet providers that we've configured in our WAGMI config. And now, rather than using is loading, the use connect does not have a parameter. All this are from the dummy data, if you remember. What it has is pending, right? So if you once you even type is, you're going to see is error, is idle, so it's pending, right? So in connecting, this is the function that connects the function. This is the list of connectors like injected, MetaMask, WalletConnect, and the is pending is to know if the connection is pending, right? So this is what the use connect from the WAGMI hook does, right? So from the use disconnect, we can also do const disconnect is equals to use disconnect. So this is also a function to disconnect. Now to access the address of the wallet that is connected, we can also do const address. We can do we call the user account and we destructure the address. This is how we know the address that is connected, right? And this is connected is to know the state if it's a boolean of true or false, to know whether a wallet is connected. I hope that makes sense. So that is what we have here. Now, what we're saying in this conditional statement here is that if an address is connected and we have the address value, which will be an OX string, right? We want to show this. We want to show connected wallet and we want to show the address, right? So what we are simply doing here is that we are slicing the address, right? We're slicing the first 6 strings, then passing a dot, dot, dot. You understand this is JavaScript and JavaScript approach, and we're slicing the last 4 too. So what you're going to see, addresses I think are 32 long. Is it 32 or 36-bit string? So we don't want to show all the old fractions to users. That's bad UI. We want to just show a portion of it. So if a user is connected and we have the address of the user, we want to render this, right? Then what we're saying here is that if a user is not connected, we want to show connect your wallet. Just like is loading is not defined. Okay. So let me just change every is loading. It's because, we do not have is loading here. We have, let me change it to is pending, right? We've changed that is loading to is pending. So that should fix the error. So what we are saying is if a user is not connected, we want to show connect your wallet to interact with the blockchain. And that's what you're seeing here because a user is not yet connected. A user is not yet connected, right? So we're moving from the demo implementation to the real implementation. So this function here is saying on click connect. Now the issue with this function is when you say on click connect, okay, let's try it. Let's say I click on MetaMask. You see, it does not open. It does not open. Let's check out. What could it be saying? We shall have this hydration field because the server rendered blah, 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 blah. So we are not having that connection. And the reason being that we are not specifying what connector we want to connect to. So to do that, you can just easily do connector. We can pass the connector here. So with this, we're telling our WAGMI configuration to connect to these specific connectors. That is, what we did here. Okay, I forgot to explain this. If you're familiar with mappings, now these connectors is an array of data, right? So if you look at our WAGMI config, these connectors is inside an array, right? You know how to write an array now, right? In a square bracket, A, B, C. So it's in an array, right? This is in an array. So we're simply mapping over the array. So we're doing connectors.map. So for each object in the array, we are actually mapping over it. So when we do connectors.map for each connector, we want to connect to the specific connector that is being clicked on. So we have to pass the connector in here, right? So that is how we connect to our wallet. So if we do connect MetaMask, you see that it does pop up. So connect. So we can hit connect and we are connected. So if you head back, we're saying loader is not defined. So I think loader, okay, I think I did not import this from Lucid Reactive. So we see that the address is now connected. What address? Now this address, this is the string, this OX thing that that I explained here. We sliced the address. If I removed all of this and I just said address, you're just going to see a long string of text, which is not really fine for users, right? So we want to slice and split and do all of that. We want to slice here. So you see that this is much UI intuitive, right? So this address 31, if you come to the MetaMask, is the address that is currently connected. Can you see 31? Now, there's one other thing I would love to say when we talk about connecting wallets. Now, firstly, let's say by default, a user wallet was on another chain. Let's say the user wallet was on, let me switch to, so let's say a user wallet by default, a user has, definitely user is familiar with the blockchain. He has connected to multiple wallets over time, right? And the wallet that the user on, the wallet chain or the network that the user on is different from what we have configured here. We want to always switch the chain to. So to do that easily, so it's not rocket science. Most of the things that you need are already pre-established in WAGMI. So you can use the use switch chain. So if you check the documentation, you import the use switch chain from WAGMI, then you follow this implementation to switch the chain to the chain ID. So different EVM chains have different chain ID. So I would explain this in a bit. So if you come to WAGMI config, you know that we imported quite a number of chains from WAGMI slash chains. If you click on mainnet, you know you hold command if you're on the Mac, or you hold control if you're on the Windows. If you hit command or control and you press on it, you're going to see that the mainnet has an ID of 1. And this is the native currency symbol, blah, 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 and all of that stuff. So if you come to Sepolia, you're going to see that Sepolia has a different chain ID. Then why is it taking time? So Sepolia has 11. Ignore this underscore. Sepolia's ID is 1115511, right? Then Avalanche is 43114. So different chains have different IDs. So to switch chains, you simply just need to. So just make sure that you get very, very familiar with the documentation. So in this simple step, you can easily connect a wallet, right? So to disconnect, we follow suit. We import the use disconnect, right? We import the use disconnect, then we destructure the disconnect from it. So when the user clicks on the disconnect button, which we have here, you know now the user is connected, so this component is going to render. If the user clicks on disconnect, we're simply just going to pass the disconnect here. So if a user clicks on disconnect, it's going to go away, right? So that is how to connect a wallet easily in few steps. So WAGMI gives all of this functionality off the hook. So to use WalletConnect, you have to go to just write WalletConnect project ID on your browser. So I'll do reown project ID. So once you come here, there should be a place to get the project ID. So they're telling you to go to dashboard. Your project ID can be obtained from dashboard.reown.com. So you can create an account and sign in. So to use MetaMask, what you have to do simply is come to your WAGMI config. You also pass, to use WalletConnect, do WalletConnect, right? But to use WalletConnect, we have to specify the project ID in here. But why I do not want to use all of this is because of I just want us to walk straight to the point, you get. So that's how to use WalletConnect. I hope that is clear, right? So with these simple steps, we've been able to connect a wallet easily. So we also want to move into, so if you want to actually walk to using a third-party integration, the advantage of using a third-party integration like ConnectKit is because it gives you like a very, very nice UI out of the box. So if you go to the ConnectKit guide, you follow through their documentation, you also have to install this. Then you're going to have a UI more like this with the ConnectKit or Rainbow Kit. So all of them, it gives you like a much more intuitive design for user experience. So basically, this is how to set up the Connect wallet. So just make sure that you read the documentation, and you know AI is your friend also. So now the next step will be to display our wallet balance. We want to render the wallet balance to for the connected address. And also we want to show the networks that we have configured in our WAGMI config, right? So this is the networks that the users will see that is enabled on our app. Now, you remember that all these data here are still mock data. The only one we've modified to be dynamic is the connect section that we fixed, right? So we want to render the user wallet balance to them, and we want to show the networks that we have configured or the chains that we have configured in our WAGMI configuration. And when a user clicks on whatever chain, the network should switch to the chain that the user selected. So now what we have to learn, what you'll be learning is how to render the user's balance to them and also how to switch chains, switch across various EVM chains. Now, this is what I want you to understand before we go into coding. Now, you can see that the balance here is ETH, right? So in the world of blockchain, we have what we call native currencies, and we also have what we call tokens. So for better clarity for you and for developers who do not really know about the Web3 space, a native currency or a native coin or a native currency are currencies that are unique to a blockchain, while a token are currencies that are built on a blockchain. So like what you can see here, you can see different networks. We have Ethereum mainnet, we have Polygon, we have Optimism, and we have Arbitrum One. Ethereum mainnet has its own native token that is called Ether, ETH. Polygon itself has its own native token called Polygon. Optimism also, Arbitrum One. Optimism's own is Optimism Coin. Yeah, so I think. So on these networks, you can now have tokens. So if you look at this dummy data here, right, if you can look at this dummy data, we also have the read contract data. You can see USDC token balance. USDC is a token. It is not a native coin. So if you need further clarity, remember I said AI is your friend. You can always like go to ChatGPT and just ask for clarity. And you can ask, what's the difference between a native coin and a token? So let's go into coding. Also, before we go into coding, we have different types of network. If you go to chainlist.org, you're going to see Chainlist says that it helps users connect to EVM powered network. EVM means Ethereum virtual machine, and there are different networks that are EVM compatible. For Ethereum mainnet, the chain ID is 1. For BNB Smart Chain 56. For Base, it is 8453. For Avalanche, it is 43114. Right? So different networks have their different chain ID. So in switching chains, what you need is that chain ID. And you're going to see that as we dive into code. Remember that I said that if you go into our WAGMI config and you over on the chains that we imported from WAGMI/chains, if you click on Avalanche, you're going to see that the chain ID is 43114. So what we'll be doing now is we want to render a wallet balance. And we also want to learn how to switch across the chains that are configured in our WAGMI config. So in our situation, rather than having all this mock data, our own will be Avalanche, Ethereum, mainnet, Sepolia, and Avalanche. Why? Because that is what we have configured in our WAGMI configuration, right? So I want to throw a question as a front-end developer, as a React front-end developer. Imagine you have a decentralized application and a user comes into your app for the first time. Without connecting a wallet, do you want to render the wallet balance to them? Yes or no, yes or no, yes or no? The answer would be no. Because the only way a user can see their balance is when they have connected a wallet. Imagine you're using First Bank, Zenith Bank, or you're using Lloyds, or you're using any bank, and you do not have an account and they are showing you a wallet balance. You're going to go crazy that, what do you mean? So as front-end developers, you only want to render the wallet balance to them when they are connected, when they have their account in sync with your decentralized application. So that being said, let's get into coding. Now, in our page.jsx, remember that these components are the one rendered, right, in our page.jsx. And so far, so good. The only one we've tweaked is the wallet connection. You see that the wallet connection imported here is no longer from the mocks data, right? So we also want to have the balance display, not from the mocks. We want to have real data, right? So we can go to the mocks, go to our components, get this old balance display that is in the mock, because we still want we want to use the same UI, right? You can copy it. Then we can now go back to our components, create a component called balance display. So that will be balance display.jsx. So I'm pasting this in. Now we have this, so we can go to our p.jxs. We no longer want to use the balance display from mocks. We want to use that from /balance display. right? So now we already have the one from balance display. Okay, so what it means here that in our balance display, we should change this import. Definitely because the route has changed. So it will now be mock slash WAGMI mocks. So that should fix the error. Now we want to now implement real data. Firstly, we want this component to only show when a user is connected, right? So we can use conditional rendering. How? Remember that we talked about the user account hook. If you remember, when you go to wagmi.sh, if you come to the hooks, if you click on user account, you're going to see hook for getting the current account. And it comes with quite a number of things like the address, chain number, connector, boolean, is connecting, is reconnecting, and all. So we can get the is connected param, right? We can do structure is connected, and that's a boolean. So we can do is connected. We can do structure is connected from what? From use account, right? So this is a boolean of true or false. It's a boolean type of boolean. So we can do if only when a user is, we can do if is connected is true. That is the only time we want to render the balance component, right? So this should work. Okay, it's giving us an error. You're attempting to call user account from server because yes, I've been wanting to mention this. We're having this error because the user account is rendered on the client side, but Next.js is configured for SSR for server side rendering. So at the top here, we have to say use client to fix that error. So if you're using React or Vite, you necessarily do not have to be passing this keyword here because I think React and Vite are configured to work on the client side by default. So because we're using Next.js and Next.js is SSR server side compatible, we have to declare that to use client component. So that should fix our error. Now you can see that because nobody is connected yet, the wallet balance component is no longer rendered. So it's only when a user is connected that we are going to see their wallet balance. And I think that is much more UI. It makes sense more for users to see, right? For the user experience, for the UX. So now, if we connect to MetaMask, it's installed in my browser. You can install it from Chrome extension, right? We're going to see we are seeing the component trend that remember the balance is not 1.234 ETH. We've not actually fetched the balance dynamically. It's still showing the balance in the mock data, right? But now it's only when a user connects. If a user disconnects, it's no longer going to show. So if a user connects, it's going to show. So we fixed that. That's one of one. The next step is learning how to fetch the balance. So how do we go about that? We can actually console.log. We do not need to use the use balance from WAGMI mocks. We want to use that from WAGMI itself. So if you go to WAGMI documentation, wagmi.sh, if you come under the hooks, if you look for use balance, this use balance hook is the hook used for fetching native currencies or token balance. You see that a native currency is not the same as a token balance. And that was the explanation that I was trying to make earlier. So to use this, we can easily do import use balance from WAGMI. So we can do use balance, right? We've imported use balance from WAGMI. Now, remember that this is from WAGMI, from the mock data. Let's use something that is more real. So to do that, the documentation says that we can easily do const result equal to use balance, then we pass in an address to get the balance of the particular wallet connected, the address of the wallet connected, right? So we can paste this here. So now the issue that we're having is that this address here is hard coded. Now the question is, how do we get a dynamic balance for whatever address that is connected? Because we always will not know the address. Our app will be deployed on this internet and different users can come, different users with different wallets will connect to our platform. How do we render the balance for the unique address that is connected to our wallet? So we definitely do not want to use an hard-coded address. But for much more clarity, let's console.log results, right? We're going to get an error that balance the formatted and balance the symbol is not defined, right? Because this is how it is structured in our WAGMI mocks. So let's just console.log this out. Because what is balance is not defined. It was only defined in the mocks, right? So let's just see what this is going to output from WAGMI, right? Let's see what it's going to output. So what we see when we open inspect, we're seeing prosy object, blah, 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 object key. So I think something is wrong. A contour.log results. So let's just get straight to work. Let me leave this back. Let me leave this. Let me uncomment this. So now, to actually use an address for the connected wallet, what do you think we can do? Now, remember that this use account comes with, we can destructure the address from the user account. That is the account that is currently connected. We can destructure the address. So rather than having this hard-coded address of 32 or 36 strings, we can just pass address. So this automatically would dynamically fetch the address of the wallet that is connected to our application. Now, what would this result be? To do this, also, if you go back to the documentation, is loading is not defined. Okay, so I'm going to fix that, but I want us to go to use balance. If you scroll down, the use balance hook also comes with a lot of things. It comes with, you can pass in the block number to get the block number to get balance at that particular block number. It comes with the chain. You can pass in chain ID configuration and all of that stuff to it. But to do this easily, it also comes with a lot of enabled initial data and all of that stuff. But to do that easily, we can also destructure its balance. I'm just going to escape and I'm not going to answer Copilot. We can also destructure is loading, I mean to say, from use balance. So if you start typing, you're going to see there's quite a number of things. Is error, is fetch. So we're going to destructure is loading from use balance. You know, we did something similar like that in the mocks. So you can also destructure error in case there's an error when calling the use balance hook. Then to see the data of a balance, you can do data, right? So remember that in our mocks, we called to show balance, we just do balance.formatted, balance.symbol. I'm going to explain this. So this data in itself, if I console.log data, and then let me just comment all of this out. This is loading. If I console.log data and I go back to our website, right? Are you seeing what is showing? We're seeing decimals of 18, formatted 0, symbol, AVAX, value 0. So what it means is that it is showing the balance, this data here, it is showing the balance of the chain that is currently connected. So it means that this address balance is 0. It has a decimals of 18 and the symbol is AVAX. That is, the chain that this address is currently connected is AVAX. How is it AVAX? Because by default on my own wallet previously, even before this tutorial, I have AVAX configured, right? So, and you know that in our WAGMI slash chains, we have Sepolia, Mainnet, and AVAX configured here, and we pass it as chains. So the data is already showing you the balance. This formatted is like the string version of balance, something more nice, a more formatted, but the value itself is 0n. And when you see n, this means it's a big int, right? It's a big int data type. So the value is 0, but it's formatted to string as 0, and the symbol is AVAX. So why you're seeing the decimals of 18 from that data is because in Web3, value by default is tracked in Wei. So you can check this up, WEI, and Wei is 10, Wei simply means 10 raised to power 18, and that's why you're seeing, so tokens, native currencies by default, the value is in Wei. Their format is in Wei. So when you format it to be nice, to string, then you're going to get something much more user pleasing, that is to the eyes. But by default, it is always to the power of 18. That's why you're saying that it's to the decimals of 18. But we do not need all of that. Now, what we need in our balance display is, since we're using balance here, we can easily rename, not in this mocks data. Let's go back to the real one. In this data, we can easily rename data to balanced, right? We can easily rename data to balance, right? Then when we rename data to balance, we can console the log balance. We no longer need this. We've checked everything from data, right? So right here in our code, what we're saying is, if it is loading, show the loader. Where is this loader from? From Lucid React, right? Show loader and show loading balance. If there's an error, show error loading balance, right? Then if there's no error, we are going to show the balance dot formatted. What is that formatted? 0. That is everything, right? You know that we've renamed data to be balance now. So we tap into balance dot formatted. Then we now pass in the symbol of the chain, balance dot symbol, which is now AVAX. So if we save this and we come here, we should see 0 AVAX. Let me reload. So we see 0 AVAX. I hope that is clear. So what we're simply doing here is we are fetching the connected address, right? We're fetching the balance of the connected address where the structuring is loading error, and we're destructuring data. This data, you see that it has 4 objects, decimals, which is by default to 18, the formatted string, the symbol string, and value begin. So from this balance, we are tapping into the formatted, which is like the balance of the connected address, and the symbol is the current chain that the account is connected on. So with this, we've simply gotten how to display the balance for a connected account. Now, the next thing, which is very, very paramount, is how to switch chains. So there are certain decentralized applications that are cross-chain compatible, like platforms like Chainlink, and all of that. Chainlink is a very awesome Web3 platform. I'm not promoting any project here, but it's also an awesome Web3 platform too. So we want to be able to switch in, you get. Now remember that everything here are at coded data, Polygon, Arbitrum Mode. So what we want is when the user clicks on this Ethereum, on this particular select option tag, we want them to be able to switch to their desired chain. And that is what we've configured in our WAGMI chains on our app, right? So let's get into working with this. So now what we currently have in our pay.jsx is a network info component from the mux data. I want to use real data now. So we can easily copy all of this, right? Go into the components and create network info.jsx. Then we paste this. Now, what do we want to do at first? We want to show this Ethereum mainnet here with the green circle is currently showing the account that the chain that the account is currently on, right? So what we want to do first now is we want to show the chain that the account is currently on, and this does not match. Because the wallet balance is showing 0 AVAX, it means the chain is currently on AVAX, but you're still having Ethereum mainnet, and this is because it's still a mug data. So let's get into modifying this. So I want to throw a question to you. How do we do this? To get the current network that a account is currently connected on, anytime you get to get the chain that the account, so we're going to use the use account from WAGMI. So we're going to do import use account from WAGMI. Now, to also fix this, we can do const use account. So how do we get the chain that the account is currently on? We can easily just do chain. So with this, we're going to know the chain that the account is currently on. Now, if you console.log chain, you're going to see that chain is quite a number of things. So if you inspect, I just do option command I. So if you inspect, you're going to see, I don't know, there's no yet log. In our pay.jsx, we also have to change the imports here from mux, right, to /component/network info. So, right, because we are now working on something real, not just the more. So we should see chain logged here. Now you can see that chain is quite a number of things. Chain is the block explorer, is showing snow trace, that is AVAX. Snow trace is for AVAX if you're familiar. Default snow trace. Then it's showing you the chain ID 43114. Remember that Avalanche's chain ID is 43114. Just ignore the underscore Avalanche and all. Then also it is showing you the name. So what we can do is we can do chain.name to show the particular chain here, right? So this is chain, but chain is quite a number of objects. So we want to, in our network info, what do we want to do? We've logged chain, we've seen what chain is. So in our current network here, what we just want to show is chain.name, right? We want to show chain.name. And to handle potential null, well, we can just put a This is how you can handle in case the value has not yet loaded. But let's just do chain.name. So you can see that now it is chained to Avalanche, right? So it means that our current chain is Avalanche. I hope that is clear. Yeah. So what we can do now is in our Ethereum mainnet, when the user clicks on this select tag, we want to show them quite a number of chains that we have configured in our WAGMI config. We don't just want to show them that dummy data. We don't just want to show them all of this here. We want to show them the chains that are configured in our WAGMI config, and that will be mainnet, Sepolia, and Avalanche, right? So how do we do this? We want to show them the chain. I want you to start thinking in that manner. What hook would we be using from WAGMI? Take a guess. So we come to wagmi.sh and we're going to use the use chains. Let's check it out. So the use chains is the hook for getting the configured chains. So what configured chains? The chains that we have configured in our wagmi/chains. So we have mainnet, Sepolia, and Avalanche, and we've passed it here in our create config in wagmi config, right? So what we can do is we copy this, import use chains from WAGMI. It helps us get the configured chains. So we go into our network info, we import the use chains, right? We import the use chains from WAGMI. Then this is how to now get those chains. So we can just do const chains is equals to use chains. So if we paste that in here, right? Const chains is equals to use chains. We can now actually access the chains that we have configured. And that would be mainnet, Sepolia, and Avalanche. So now remember that this chains is an array. If you console.log chains, let's console.log chains also. If you console.log chains, inspect, you're going to see that this chains is an array of 3. I remember that an array starts from 0, 1, 2, and 3, right? So if you check array, you're going to see 0, 1, 2, and 0, 1, and 2. So it's a length of 3. This is 1, this is 2, and this is 3 because arrays start from 0, right? So this is an array. So if you notice, the array of 3, per object in those array, they have quite a number of data. So they have contract, fees, format. So what we'll be rendering here will be the particular chain.name because every chain has quite a number of objects, right? ID, name. So we're going to map over, we're using the map method in JavaScript. Rather than doing networks here, we can easily take all of this out, right? We can just do networks. We can just do chain.map, right? Chain.map. Then for each network, let me do chains. Let me call this chains. Yeah. Chains.map. So I'll now do chain for each chain in the chains, right? I can pass in a key of chain.id using the ID as the unique key. Then the value, I can do chain to the ID, and I'm going to explain why I'm using chain.id as the value. Then here I can now use chain.name. Remember that here, each chain has an ID. For mainnet, it is 1. For Avalanche, it is 43114. And also here, we're passing in what the user will be seeing in the option tag will be the chain.name. That is the name, right? So we can save this. So let's see if this works very well. Let me reload. Okay. So it works. So let's see if there's a potential issue. So if I click on Sepolia, it's changing to Sepolia, it's changing to Avalanche if you can see. But at the top here, it is not changing. So what we want to do is when a user clicks on Sepolia, we want Sepolia to render at the top here. So this is what will happen. When we click on, whatever is at the top here is the current chain that the account is connected on. So to resolve this issue simply, we just need that when a user clicks on Ethereum, we want to switch the chain to Ethereum. So by default, this one will change to Ethereum, right? So what can we do? We have to use the switch chain. To switch a chain, what hook would we use? To switch a chain, we have to use the use switch chain. Now let's go to our documentation and let's check the use switch chain. Now to use the use switch chain, the use switch chain is the hook for switching the target chain for a connector or the WAGMI config. So we can import the use switch chain from WAGMI. So if we do use switch chain, right, the use switch chain, then from this, the documentation tells us that we can call chains and switch chain from use switch chain, right? So we can just paste this below. We don't need chains. We already have this. We don't need chains. So we just need the switch chain function from WAGMI. Now to switch a chain, what can we do? We have to pass in the switch chain, call in this function, then pass in the chain ID that we want to switch, right? So let's just take all of that. Let's come in this onChange, this select tag is what is showing with the options, what is showing the options of chains, right? We already mapped our chains. What we can do here is pass in two functions on the onChange, right? Just simply do switch chain, then we just do chain ID. This one takes it. This is how it's written in documentation. Let's just go chain ID, then chain.id. Now, while we are having this, we do not know what this chain.id is, right? We do not know what the chain.id is. So whenever a user clicks on a particular chain, what we simply want to do, whenever a user clicks on Sepolia, we want to pass in Sepolia's chain ID to switch to Sepolia. Because by default, this network here is showing the current chain that the user is connected, which is AVAX. So when we click on Sepolia, I want to switch to Sepolia's chain. So how do we do that? How do we know the chain ID that matches here? So what can we do? For example, if I pass 1, it means that by default, let me just play this. If I pass 1, you remember that when we came to chain list tells us that Ethereum's chain ID is 1. Because I have hard coded this to 1, anyone I click on will switch to Ethereum's mainnet. Even if I click on Avalanche, it will switch to Ethereum's mainnet. What I need to pass here now is the dynamic chain ID for each chain. So if I come to localhost and I click on Avalanche, see that it switches to Ethereum. Even if I click on Sepolia by default is a testnet. It is still Ethereum though. But if I click on Ethereum, even if I click on Avalanche, it is meant to switch to Avalanche. But by default, it is switching to, you see that it already changes by default. So we now have to pass the chain ID. So how do we pass the chain ID dynamically? Let's think about that. Now, if you say event.target.value, remember that the value of the option keys is now chain.id, which is what? A number, right? You remember that we passed in the value of each chain. Remember that chain has quite a number of parameters of formatted, block, explorer, chain ID. So we passed in the value of each chain. And here, what you're seeing is the chain.name in these options. You're just seeing the names, but the value under the hood is the ID, right? So we can just easily do chain ID is event.target.value. So if we save this, if I click on Sepolia, if I click on Avalanche, it does not work. And why is that? Are we having anything in the console? We are not having anything in the console. So this might be rendering it as string, right? But this must obviously be a number. So let me use number. Let me use the number keyword in JavaScript. Let me see if that would work. And Sepolia, Avalanche. So it now works. So it means that it was previously treating it as a string. This chain ID wants to receive a number, right? It wants to receive a number. So if I come here and I click on Ethereum, see that it automatically switches to Ethereum. And because by default, in this place, we are using the current chain.name. So the current chain.name, for you to better understand, I can just rename this to current chain. I'm just naming it to current chain. So what this is doing is that it is listening for the chain that the account is currently on, and that's what we are passing here. I can just do current chain.name, right? So I think this is much more better. And we are switching the chain by calling the switch chain from the use switch chain hook in WAGMI. And we are passing the chain ID dynamically. Remember that we already said that the value for each chain is the chain.id. So when we are clicking on switch chain, what is receiving here is the chain.id. So when you click on Avalanche, it automatically switches to Avalanche. I hope that is clear. So the next step will now be able, is now us to read a token balance and to write to contract. So what does it mean to write to a contract? What it means to write to a contract is to update the state of a contract. So, in traditional APIs, we have different HTTP methods. We have the get, the put, the post, and patch, right? So the get is used to fetch data. The put is used to update a data entirely. The patch is used to partially update, and delete is used to delete the data. So what we are doing with this wallet balance in blockchain terms is that we are fetching data. We are reading from the blockchain. It's not as if you are fetching, you're getting a request, right? But now, in sending transactions, when we see anything like write to a contract, it means that you want to update the state of the blockchain. So in updating the state of the blockchain, it's more like post method, as if you want to update data in a database, right? So with this wallet balance, you're fetching from the blockchain. But when you want to write to a blockchain, I mean to say, because you're updating the state of the blockchain, you have to pay what we call gas. You have to pay a fee. And we're going to get into that when we start working in the right contract. So we have majorly two functions as front-end developers. You read from the blockchain and you write to the blockchain. So in reading from a blockchain, you do not need to pay gas. But to write to a blockchain, you need to pay a fee because you're updating the state of the blockchain. So do not get very, very confused. The more you dive into the world of Web3, the more you're going to understand all of it. Now, the next step is to actually read contract data and to actually write to a contract. Now, in our code, you can see that we are actually reading the USD token balance in this dummy data for the address that is currently connected, right? We want to read to a contract and we also want to write to a contract. Now, we want to read the USD token balance for the address that is connected, right? Now, firstly, as front-end developers, we are firstly front-end developers before we become Web3 front-end developers. So what do we want to do? If a user is not connected, we do not want to show them read their USD token balance, or we don't want to show them that they should write to a contract. The first step is that they have to connect their wallet to see the functionalities that our dApp can give, our decentralized application can give, right? And also, I want you to pay attention that in this particular place, we are reading a token balance. So what it means is that, I said earlier that a native currency is different from a token, right? So a native currency is the underlying currency for a blockchain, while a token is built on the blockchain. So you can hack like your AI platform like Claude or ChatGPT to actually like give you much more insight into what the difference between a token and a native currency is. So firstly, I have a question for you. Based on everything that we've been doing, how do we not show all of this to a user? The read contract and the write to contract, if they are not connected. How? I want you to think about that. Okay, so to do that, firstly, let's copy this contract read from the mock, right? Let's copy the contract read from the mock. Let's copy everything here. And let's put it in our component so that we can. So contract read. Right? Let's copy everything in our page.jsx. Let's change it from mocks to dot slash component slash contract read, right? Contract read. So we have this now. Now we're using this because we want to use real implementation. So we can easily to not show this UI to a user who is not connected. What can we do? So we can do if it's connected is true. That is when we want to see this particular component. So that is sorted, right? If a user is not connected, it will not show. So if it's connected is true, we want to render this. So now how do we read a token balance from a contract for the particular address that is connected? Now, I want you to pay close attention. If you understand this, you're going to have like an head start form that is different than most developers or Web3 developers might struggle with. You're going to like grab this very easily. Now, what is a smart contract? Or what is the contract data that you want to read? Everything that you see that exists on the blockchain are most typically smart contracts. I'm not talking about traditional data. I'm talking about everything powered on the blockchain are contracts, are smart contracts. And what are smart contracts? In very simple terms, Smart contracts are self-executing code that run on the blockchain. They do not need to be interfered on. Do you understand? So tokens, NFTs, decentralized application, many things. If you decide to create a decentralized written application, it's going to be a contract that runs on the blockchain by itself. So smart contract are autonomous code that executes without third-party interference. That is why they are meant to have a decentralized nature, right? So USD token balance is a contract on the blockchain and it exists on quite a number of blockchain. It does exist on Ethereum, it does exist on Binance Smart Chain and quite a number of blockchains or chains or networks. We've explained what chain and networks is. So how do we read the token balance of a particular account that is connected to our address? So we have different types of tokens. We have USDT and USDC is a type. So in this situation, we'll be exploring USDC on what Ethereum's blockchain, because Ethereum is like the mainnet, and once you understand it, you'll be able to do it for every other blockchains. So now, to read a contract data, what hook do you think that we will need? Let's go to WAGMI.sh. The hook we'll be needing would be the use read contract. Now, if you read the use read contract from WAGMI, it says this is the hook for calling a read-only function on a contract and returning the response. A read-only function on Solidity contract is donated by a peer of you. This is more technical terms for backend Web3 developers. Say they can only read the state of the contract and cannot make change. So let me buttress this again. When you're reading from the blockchain, you're not changing the state of the blockchain. It's just as if you're sending a GET request from a database. You just want to fetch data. But when you are writing to a blockchain or a contract, it means you want to update the state of the blockchain and you're going to spend gas because you're necessarily initiating a transaction. So to use the use read contract from WAGMI, we're going to just copy it. Then we're going to head back to our code base, right? In our contract read, the one we want to use dynamic data, we're going to import use read contract. So after doing this, we would need the ABI, right? We need the ABI. And I'm going to explain. I know you're asking, what is an ABI? And might not sound very, very familiar to you. So what is an ABI? So an ABI stands for Application Binary Interface. So the ABI is more like the structure of what a contract looks like. So the ABI shows you what a contract looks like. It shows you what the input of the contract is. It shows you what the output of the contract is. It's just as if you put in A, the ABI tells you what you expect to be returned. So let's say the person that wrote that contract, the person says anytime you put in boy, you're going to receive girl. The ABI would not show you the particular boy again, it might just show you gender, male, the kind of data type that you expect to be returned. Do you understand? So an ABI is an application binary interface. It's more like the API between a client and a server, right? So the ABI tells us the structure of a contract that we want to interact with on our app. So to get the ABI in this situation, because we are dealing with USDC, how do we get the ABI? Now, if you do not have any idea about blockchains, there's what we call the block explorers. Now, on this our chain, we have quite a number of networks, Ethereum, Sepolia, and Avalanche. To get the ABI of a particular token, in this our situation, it is USDC, right? You need to go to the block explorer, and it is not magic. If you come to our WAGMI configuration, we have quite a number of chains from WAGMI/chains. We have mainnet, Sepolia, and Avalanche. If you hold command or over on it, or you click on it, hold command and you click on it, you're going to see a particular field called the block explorers. And the block explorer for mainnet is etherscan.io. If you come to Avalanche, if you press on command on Mac or control and click on it on Windows, you're going to see snowtrace.io, the block explorer for Avalanche. And for Sepolia, it is sepolia.etherscan.io. Now, also, when we talk about Sepolia, let me quickly make this explanation. Sepolia is a test net. It is not a mainnet. Avalanche is a mainnet network. And Ethereum itself is the mainnet, like the Oga Pata Pata but Sepolia is a testnet. So when I say Oga Patapata, it's like the forerunner. So Sepolia is a testnet. So testnet is very important for developers in the sense that when you're building a contract or you're testing a contract on the front end, sometimes you want to be sure that the things work well as you plan them to be. More like development and production, right? So you do not want to spend your real money. You want to spend fake money to see that the contract or your app functions just as it is, right? So we're going to dive into that when we want to like make transactions. But for now, let's just learn how to read transaction. So to get a contract ABI, let's say on Ethereum, we have to go to the block explorer URL, which is etherscan.io. So to get the ABI for USDC, we have to go to etherscan.io because that is the website. Then we can easily search USDC, right? So we're going to see it. Then to get the ABI, we simply click on contract. It has quite a number of things like that gives you quite a number, but we need the contract, right? We come to code, you scroll down, you see the contract ABI, right? It has quite a number of things and all of that. Now, by default, I want you to also pay attention here. By default, this is the normal way you would do it. But some contracts do have proxies. Once you see read proxy, it means that the ABI that you want to use is not directly the one listed here because there's a proxy address, right? Once you come to etherscan.io, search for a particular token or contract. If it does not have a proxy, you do not need to check the proxy address. You just need to come to ABI and copy it here. Click on copy, right? But because this has a proxy, let's click on the read proxy. So you see that the ABI for the implementation contract is at. So we'll be using the ABI from this one. So let's just click here and let's come on to contract and let's click on, this is where the ABI is. So we can just copy it. Now in our code, because we're importing ABI, let's create an ABI file, right? So the way I like to do mine personally is that in the root directory, I like to create a folder called constants, right? Because ABIs do not change. I just call it abi.gsx. Then I'll paste everything here. It's quite a lot. It's quite a lot, but everything is in an array, right? But because we'll be using it in our contract read, we can export it. I mean to say, I can do export const. I can do ABI, or should I do USDC ABI? Let me just do this. Don't mind me. You can use anything that you like. So right here, rather than using ABI, I'll just do USDC. So I'm going to import USDC ABI. So I've already imported that. Then I have imported my ABI right at the top. So the code logic here now also says that to use this, we can just copy all of this, right? Const result, use read contract, blah, 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 blah. Then I can just do this here. So const result is using use read contract ABI. We have this ABI to be what? I'm going to rename this to USDC ABI because that's what I'm using. I'm not just using what they said. Then the address. What is the address? The address is the address of what? USDC. Because in this our situation, we're dealing with USDC, right? So to get the address of USDC, we can easily just go back. We already searched for US. This is USDC. We can copy the token address. This is the address. We copy it. Then we go back to our code. We change it here. Now, after we've done this, we have the ABI of USDC, we have the address of USDC. Now, for every contract, there are functions that exist on contracts. We have different types of functions. Now, if you go back to etherscan.io and you click on read contracts here, normally you're meant to see a whole lot of functions here, but because USDC has a proxy contract implementation, we have to click the read as proxy to see everything, all of the functionalities that we can read from that particular contract, right? So you see that you can cancel authorization. This, you can check the domains operator, you can check the allowance, the balance of. Now, if you remember here, this has a function name of total supply. So when you're reading from a contract, you have to specify the function that you want to read. So in the WAGMI implementation, they said total supply, but us, because we are dealing with balance, we want to check the balance of the account of the USDC address. Let me explain. We want to check the amount that the connected address has for USDC. So to do that, we have to check what? It is not the total supply we want. We don't want the total supply of USDC. This is in decimals of 18. What we want is we want the balance of, and this is a function. If you notice, the balance of is telling us that it takes in a input of address and it outputs a uint 256, which is an integer. That's what it just means, a positive integer. So uint means unsigned integer. So we have to change our own function from total supply to what? Balance of. Balance of. Now, we've changed the name, but I want you to pay close attention. When you check total supply, you see that total supply does not show you that it takes an input. It just shows you that it returns a uint 256. But when you come to balance of tells you that it takes an address and returns a uint 256. So how do we pass an address? Now, the address in our own situation will be the address that is currently connected, right? So in a situation where you are using total supply, you do not need to pass a argument to your use root contract. But because the balance of takes a parameter or an argument of account of address, we have to pass arguments. So we pass it as args. It means argument. Args. So how do we get the wallet address of the current account that is connected? We use the use account, right? So we do address, then we pass in the address here. Address. We pass in the address. Now, if you notice in our code, we have quite a number of things like is loading. The loader is from Lucid React, right? The I2. So we have things like is loading. How do we get all of this? We simply just have to destructure it from is loading, right? Error, in case there's an error. We also want to destructure what? I can remove all of this. That dummy is loading. I can even remove the token balance that is static. Then is loading, and also want to do data, right? Let me still leave that static token balance. Let me just do data, right? Now, with this approach, we've simply fetched the balance of, we don't need this undo read, this is for dummy data, right? We simply fetch the balance of the particular address that is connected for the USDC. So anytime a user comes to our application, we are going to check the USDC amount that the address has. So you can, if you understand this, you can do it for any other token that exists on any given blockchain. So let's console.log data. Let's console.log data and let's see what we have. Handle read is not defined. Where do we have that here? Handle read. Handle read. Let me just search handle read. On click, we do not need this. We do not need handle read. Let me refresh. Now, we are still having this accoded amount. So let's check what we have for our. So we see that, I don't know if you can actually see this. It is 0n. This is 0n. This is 0n. The balance is showing, the data is showing 0n. 0n. That is what it's showing. So when I console.log data, it is showing 0n. So what we can do is now passing that data in here as token balance. So I can rename this data. I can just say data is token balance. I can remove this, and I can now pass in token balance here. So to convert that zero, data is not defined. Data. Okay, console.log data. So we are now saying 0 USDC, right? We're saying 0 USDC. So with this, it means that this account has a balance of 0. That is what it means. It means that I have a balance of 0. So for better clarity, if you come down here, you would see that this has a balance of, this is the exact implementation for what we just did. It has a balance of, and it also takes argument. So the argument is the address that we want to check the balance for, right? I hope that is clear. So with this, we simply learned how to read from a contract. We simply learned how to read from a contract. So There's it also the use read also can take a query. Yes, it can also there are certain implementations that you can use to only fetch if the wallet is connected. But since we're already using the is connected, if you want to only check for the balance when an address is connected, you can simply do query. You can do query, do enabled, then if address is connected, that's what it means. The two exclamation, that is what it means. Then if you always want to watch, if you always want to watch, you can just do watch true too. So in case the balance somebody sends money, it's automatically going to be watching for changes in the balance. Now we've sorted this read contract. Now if you notice in the what else? What else? Are we done? Okay, I think we are done. Let me just change this contract address here because we're dealing with USDC. Let me just change it here. So with this, you've learned how to fetch the balance for a token that an address has. Now, how do you write to a contract? That will be the next thing. How do you write to a contract? Now, I think we'll be rounding up the tutorial here because of time. Like I was thinking that this tutorial would just be like for an hour, but for the recent transactions, we might cover it some other time because the implementation is a little bit different. But how do you write to a contract? So the next step now is to write to contracts. We have to learn how to write to a contract. We've learned how to read to a contract. I remember that I said that reading to a contract is like fetching data from a server. So when we read from a contract, we are simply getting data from the blockchain. But when we write to a contract, what we are doing now is that we are updating the state of the blockchain. It's like a post request. You want to create something, you want to initiate a transaction, right? So now we want to learn how to write to a contract. Remember that the data here is a dummy data, right? We've updated the one for wallet balance, for network, for the read contract data. And what we have left now is to write to contract. So let's proceed to do that. So to write to contract, let's copy the write contract right here from the mock. Let's, just like we've always done, let's go to the component. Let's create contract write dot gsx. Then we paste this here. Then we'll go into our page.gsx and we now change the imports here. In the imports here, contract write. So what we have here now is the one in our company. So we can proceed to update it. So the first question is, how do you write to a contract? If you want to read from a contract and we use the use read contract, how do we write to a contract? We'll also use the use write contract, right? So let's go to wagmi.sh and let's look for the use write contract hook. So that would be use write contract, and this is it. So in the WAGMI documentation, it says this is an action for executing a write function on a contract. A write function on a Solidity contract modifies the state of the blockchain. This type of functions requires gas to be executed. Hence, a transaction is broadcasted in order to change the state. So what is a gas? A gas is a fee that is paid basically when a transaction is executed. So to use the use write contract hook from WAGMI, we simply have to do use write contract from WAGMI. So we import it like so and we can paste it at the top here. You notice that in the code we need the ABI, and in our own situation we already have the ABI for USDC. And I'm going to explain why we're using the ABI also. So I've imported USDC for the ABI from USDC ABI. Then we have to also destructure the write contract from use write contract. So far so good. We followed the documentation. Now, if you look at this code, we have the undo send. You have to understand. So the undo send expects a recipient and an amount, right? So yeah, this is where we pass in the recipient and this is where we pass in the amount. And also we have a is loading. So where do you think we're going to get our own is loading from? We're going to get it from the use write contracts hook, just like we've always done. Then we're also going to get error, blah, blah, blah. And if you notice, the button here is disabled. The send button is disabled. If is loading is true, we want the button to be disabled. If recipient does not exist, and if amount is null, You see that it cannot be clicked. So we want to do all of this. So what we want to do with the use rights contract is we want to send what? USDC to a recipient, that is a receiver. That is what we want to do. We want to basically send USDC. So the question would now be that why do I have to write to a contract when I want to send something? So unlike fetching a balance, you're getting a request from the blockchain. But when you want to send something, you want to create a transaction. So write functions are functions that when they are called, the blockchain state will be updated. And read functions are functions that when they are called, we simply just want to get data from the blockchain. So also remember that in talking about the read contract, we mentioned that we can check when we search for USDC on Etherscan. If you click on read as proxy, you're going to see read functions only, like balance of, total supply, owner, and all of that. If you click on owner, you're going to see the owner of that address. You see that it tells you the owner. But to write to a contract, you see that you need to connect a wallet, right? So in reading Axproxy, you can also connect a wallet, but to execute it, you do not need to call a wallet. But when to check the stuffs on read proxy, you necessarily do not need to connect a wallet to check, right? But to write Axproxy, you must connect a wallet. So you see, this is approved. We need to connect the wallet to do things because every function here in the write Axproxy are write functions. It means whenever you call any of these functions, they're going to update the state of the blockchain. So now to send USDC to a recipient, what write function do you think we have to call? We have to call the transfer function. And if you see, the transfer function takes in two parameters. It takes in a to address and it takes in a value, that is the amount. Remember that I said that value in Solidity is basically treated as way. And what is way? Way is 10 raised to power 18. Most data, so like USDC is actually unique. USDC has a decimal of 9, but for most ways 10 exponential 18. So just put that in mind. So to transfer, we have to call all these functions here in the write Axproxy are actually write functions. And to transfer USDC to a recipient, we need to call the transfer. And we simply have to pass in the address and the amount, like we have so here, the recipient at the amount of USDC. So let's get to work. So now we have this write contract here, and we have the use write contract. We already created the state variable for recipient, and we also created the state variable for amount, right? Now, we do not need this is loading. We simply just want to get is loading from here. Or in this situation, use write contract does not have is loading, it has is pending. It has is pending. So we have to use is pending. Okay, is pending. Now, we have is pending, right? So we can actually change all our is loading. We can change it to is pending. So is pending. Because we've updated that. Okay. So we're good to go. Now, do we have set is pending here? No, we do not have that. So we do not need set is pending. We also do not need set is pending. I'm just trying to tweak. This timeout is not necessary. I'm just going to remove the timeout and also remove this too. Okay. So what do we have to do next? From the documentation, if you check the documentation, you see that documentation on click of this particular button, we also need the ABI, the address, the function name. In our own situation, what we'll be using as the function name will be what? Transfer, not transfer form. So transfer form is also a write function. All right, this is it on USDC. This is when you want somebody to do something on your behalf. So transfer tokens from an address to another address by spending the caller's allowance. So you can always read this up later, but transfer form is like you want to allow an address to spend something on your behalf, and that is what platforms like Uniswap, Eve, does, all these DeFi applications. So you have to enable allowance. But us, we want to be the one transferring our assets by ourselves. So we want to call the transfer function. So let's just copy in wagmi.sh, let's just copy this write contract here. So in our undo send, what we can do is we can just paste everything that we've copied. Yeah. We already destructured write contract. So what we can do here is we can say if we're simply handling here that if the recipient is null or if the amount is not returned, that is the undo send should not trigger, it should return. Then we can also rename our ABI. Since we are using USDC ABI, we can rename our ABI to USDC ABI. That is Copilot automatically making that correction for me. Then address, we have to change the address of the contract to what? The address of USDC. Okay, so USDC is 6 decimals. So you have to change it to the address of USDC. Then what function are we calling? We said it's not transfer function. We are calling the transfer function. And the transfer function takes what? 2 arguments, not 3. The transfer form takes 3 arguments. The address of the owner, spender, and the allowance, the amount that the spender is allowed to spend from the owner's balance. But now the argument for transfer is just 2, right? It takes what? Transfer takes 2 and value, but transfer form takes form, 2 and value. We need the 2 address, but if you notice, what we are passing here should not be hard coded. This is the address. We need 2 arguments. The 2 address will be the address that we want to send it to, and that will be what? We can easily just call that. We already created a state variable called recipient. Then the amount will be what? Amount. Now, we already have our arguments. One thing I also want to say is, in sending this amount, we know that in our state variable, we created amount as type of string by default. But in the Web3 space or in Solidity, transfers are not usually handled like that. So what we can do is we have to pass this to a value that Solidity can treat, right, as true. So what we can do, we can use the pass units from Vim. Remember that we installed Vim too in our package.json when we, at the very beginning, when we installed Tanstack query, Vim, and all. So there's a particular function in Vim that called pass unit. If you over on pass unit, this is, it multiplies a string representation of any number by giving expense of base 10. And I'm going to explain. So this is how it is called by default. So it converts that particular value to a big int. So it multiplies a string representation of a number by a given exponent of base 10. So the exponent will be the second parameter that you pass into the pass unit. So what we can do here in our own is, whatever amount the user puts in as string, we pass in the amount, then we also pass in the decimals. And in this case, token contract for USDC is with 6 decimals. We will now pass in 6 here. With this, we've successfully created the undo send. But what is this preparing that we see here? Okay, what we can do here is, we've not learned how to, and I think we've not talked about handling errors, right? We've not talked about handling errors. So what if we have an error, especially when a user is writing to a blockchain? There might be situations where there's an error, right? There might be situations when there's an error. So what can we do? We can create a use effect. So a use effect is used to do what? Side effect, right? When maybe something happens to a dependency, we want to do something, right? So we can also destructure is error. So I can call this, I can also rename this to transaction error, right? And I can also do is success. This is how you undo errors. So we can call this transaction success. So now, success. So what we can do is we can have a use effect. It takes a callback, right? So I can do if tx success, right? I can do set transaction status to success, because we have a state variable here, and I can listen for a change in this dependency in my use effect, right? So, or I can do return. I can also do if error, right? I can do if there's error, I should refund this. Let me just do refund, and I'll do refund. So this is how we listen to error. So if there's an error, we can set our transaction status to error. So also, you remember that if transaction status is equal to success, we want to show this green check circle and blah blah blah. This is the implementation here. So if transaction status is success and transaction confirmed, blah blah blah, we want to do all of this stuff. This is how we handled everything in. And this transaction hash is actually hard coded. We should not be. So you can also see. Let me see if there's hash write contract should have. I'm trying to check the props. Okay, we'll come back to that. But this is basically how you can handle errors. I'm thinking there's also one thing I should destructure. Okay, we already have error. So if this transaction status, if there's an error, we want to set transaction status to error. But what if we want to show the actual error message? So to show the actual error message, we can also do an alert. Just for easy, something for you to say. We can also do error. We want to alert error.message. Or you want to show this message is actually going to be long. You want to just do error.short message. So let's try to implement this, but this would not work because I do not have any USDC in my balance. So let's try. Let me copy an address to receive. Let me just copy this test address. I paste it here and I do 10. I don't know why this is grey out, and I click send tokens. Loader is not defined. Okay, so we have loader is not defined. So let's see loader. So I did not import it from Lucid React. So you see that it automatically calls MetaMask. It has called MetaMask. My MetaMask is already, it triggered MetaMask. You can see that this transaction is pending. And that says you want to transfer 10 USDC. This transaction will likely fail. Why? The transaction will likely fail because I do not have 10 USDC in this connected address. So I can just cancel it. Right? So if I try it again, it's not going to work. Let's redo it so you can see clearly. So paste this and I do 10. I don't know why I grayed this out, the input fields. Let me make it darker. The color, let me give it text black. That should work. And let me do text black too. So if I hit send tokens, you see that it tries to run the transaction, but it fails. I'm transferring from account 1. Why it's telling me that this transaction will likely fail because I do not have this amount, so it will not go through. But this is actually bad. You see, it now shows you the alert of the error. User rejected the request, and that is the alert that our use effect is listening for. If there's a transaction error, I want to alert the error message. So okay. Right, and I did not undo this loading well. That's why it's still loading, but something that you can do yourself. I hope you get the concept. But there's one thing I also want to address. It's bad experience if we still allow the user to proceed and they now see that the transaction will likely fail. So what if we can pre-handle this? What if we can simulate a transaction? What if we can actually check if the transaction will go through truly? So to do this, what we can do is we can use to simulate a transaction before it actually happens, especially when users want to write to a contract, when they want to spend money. We have to be very careful. So we have to use the use simulate contract. So this is a hook for simulating and validating a contract interaction. So this will help us check if the transaction, when the user is writing, when they are making a transaction, they are writing to a contract, if it should actually go through before it's even initiated. So we have to use the use simulate hook for validating a contract interaction. And with this, we have to import the use simulate contract from WAGMI. And all of this is going to give you an edge to actually be a step ahead. So use simulate contract. So we have imported the use simulate contract. We also need the ABI. We have our ABI imported here, right? Then what we also want to do is we want to simulate the contract. So what can we do? We can copy all of this, right? Then right here in our undo send, you can use an async function. Now, an async function allows us to, as React frontend developers, if you've interacted with APIs, you should definitely know the difference between an async function and a sync or non-async function. So async functions are functions that allows you to do things before another function is executed. I don't know if I'm explaining very well, but in details, or basically, async function allows us to use the await keyword in a function, right? So let's say I come to greet you and I want to be making eba and I want to be chit-chatting with you. The ability to do multiple things in a single function without the function crashing or giving the final response is basically what an async function is. So the async function, we can use the try and catch, right? I can use the try and I can also use the catch. And this catch takes error and error, right? So I can just paste the simulate here. Then I can also take all of this here. So what I can do here is, okay, I don't know. I think I did not copy something. Okay. Then what I can do here is I can just do console.log error. Let me save this. So with this, we want to simulate this contract. I can do await, right? I can do await simulate contract. Okay, there's no need await. So what I can do here is, from this use simulate contract, I can destructure error, right? I can destructure error. I can also destructure is loading. But I think what I just want to use now is error. Let me just check error. So we want to simulate everything just as if we were doing it here. So we can just copy all of this here. We can copy all of this here and replace it here too. So we can now do if, let me just rename this error to simulation error. Simulation error. And we can now do if there's a simulation error, return, or let's do alert simulation error. Let's just do alert, not console.log. So let me have this if recipient, blah, blah. Let me just put at the very top. So you understand what we did? We checked if there's a recipient and amount. We now simulated this contract before we actually even write the contract itself. So let's go back to our code. So let me put in this amount. Let me put in this test amount, right? And I put in 10 USDC. So if I press send token, okay, we're not having anything in our console. Let me inspect. What is wrong? Console. Invalid hook calls. Hooks can only be called inside the body of a function component. This could happen for one of the line. Okay, invalid hook calls. Oh, so now, do you know why we're getting this error? It is wrong for me to call this use simulate contract. It's an hook and I'm calling it inside the function. So what I can do is at the top here, I can just do simulate contract. Or let me just, so you'll be clear, I can do use simulate contract. And I can now do error here. I can call this, I have to call it error. And I can also do simulate contract. Oh, that's not the term. We should be able to destructure simulate contract from it. Let me see. Okay. So there should be a way for us to. I'm trying simulate. It's not there. Let me try and check. Okay, so I don't think it gives us function name. So I don't know why we're having this error. I'm thinking through. I just want us to. Let me check. So I think the way we have to do that is we have to call it at the top. We do not have to call it inside of this. We do not have to call it inside of this function. I think that's where I'm getting the error because I'm calling it inside of a function. I was thinking I could destructure simulate contract from use simulate contract, but that is not working. So what I can do is I can just take all of this outside here, right? So I can do this. Yeah. So simulate contract, blah, blah, blah. So if there's simulation error, So if there's a simulation error, I want to return this. So I hope it's clear. So let's try again. Let's try again. Pasting this address. Pasting this address. Copy. Because simulation is actually important. So if I hit send tokens, it still goes through. So cancel. It should not go through. So it means I'm doing something wrong. So if there's an error, I want to alert. So this alert should be small letter, and I want to return. If there's a simulation error, here's this ABI address for it, transfer. Let me console.log simulation error then. If we have simulation error, so I refresh, paste the same, put 10, send tokens. We're still having the same thing. So our simulation is not working and something is wrong. So our simulation error is null. Check if I can actually see function name. Okay, let me try refresh. Let me just call it refresh simulation, right? Then in this refresh simulation, since we already have this, I can just call it right here. Then in my undo send, I can just call simulation, refresh simulation, right? Then in this refresh simulation, I can pass all of this. Yeah. Refresh, you should have a curly braces. Refresh simulation. So if you have simulation error, then we should alert this. So this should go first. Let's give it a shot again. Then if I do not get the simulation, it's because of the length of this video. I'm just going to leave it to you. So we're still going, it's still going through. We should not go through. So what could be wrong? Because simulation is very, very important. It's very, very, very important. So what could we be doing wrong? So how about we actually do something like this const is equal to, we get the error itself from the simulation. And so I think I'm doing something wrong. So let's remove the write contract first. Let's take it step by step. Then let's do refresh simulation. Let's see what we have. Send tokens. Just going to refresh this. I don't know how to fix that loading state, but let me just do 10 and I put send tokens. So we are not getting anything. So let me check carefully. Use simulate contract. Error. So do you simulate takes in? Okay. I'm going to pass in this. Let me pass it back here into the use simulate contract, like how it's there in documentation. So I want to refresh this use simulation in my undo send. Okay. I'm going to just do console.log error. Let me try this. Send tokens. So at 33, we're still getting that error. Right? We're still getting that error. Code can be funny. Code can be very funny. So these are the issues that we encounter as developers, right? So I have const refresh, then refresh simulation is equals to, I pass in the ABI, I pass in the address, I pass in transfer, the function name, and the argument to be recipient and pass unit. Okay. Then what else? In my undo send, I have an async function, blah blah blah. Then I'm running the simulation first. Const error is equal to await simulate transfer. So let me do await. Let me use the await keyword here. Yes, let me use the await keyword because we are simulating. Let me paste this. Sorry. Paste this and I do 10. And I hit send. We're still not getting anything. Let me console.log error. We're still not getting anything. Okay, so we can see the error. Now it works now. So when we're using the refresh simulation, we have to use the await keyword. So I'm going to take that again. So now our simulation error is working. So what we can do is, if the simulation does not go through, there is no reason why a user should be reading from the contract, right? So we can try it again, paste this 10, and if I click send transfer. So it is awaiting, right? It is simulating the contract to see if it's going to work. So we can now see the contract function transfer reverted. Why? ERC20 transfer amount exceeds the balance. So we're trying to send an amount that exceeds the balance in the connected user address. And that is why. So we can now proceed to handle this in a very nice way. Once a user clicks on this, you want to show a loading state, right? You want to show a loading state. So more like doing from this refresh simulation, you can do is loading, right? So you want to show a loading in that loader, load from load side react, right? So if this in a situation whereby the simulation fails, just return it. There's no need to proceed to write contract. So in our situation, we are alerting and returning this. So if we do this, even if I put in 10, the right contract will not go through again to not open MetaMask because I am actually calling return here. So if a simulation fails, there's no need for a user to actually access or that function. So this is why simulating a contract is very, 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 very important. So what you want to do for me as a front-end developer is style the error message. You can ask rather than console.login, the old error, you can just do error.short message, right? So you can use and design to either or toast to render the error. So now when the alert shows, or maybe it notice that what you're trying to do will not actually work. What you're trying to do will not actually work. So you can actually handle it in that manner. So you can see that the error here is function transfer amount exceeds the balance. So I think because in the alert, you just the error the short message, so it can much more better. So this is how to simulate a contract. Now, I have a take home for you. Send tokens. You see that the short message is a little bit shorter and UI nice, more nice for UI. So you see that transfer reverted, blah blah blah. So the right contract will not even go because the simulation failed. Now, I would have said we should do the recent transactions, but because of time, the implementation is a little bit different, but it's something that I might actually do later. But I hope with this, you've learned how to connect a wallet, read the user wallet balance, switch networks, how to read to a contract, and how to write to a contract. So with this, you're now a fully fledged front-end Web3 developer. And what you have to do from now is to start creating projects that you can actually host on your portfolio. So you can check out various Web3 projects and see what you can build. Now, one more thing. Now, this is how now in this right to contract, we learned how to send a token, right? USDC. What about when you want to send native currencies like Ether itself? So to do that, I'm not going to explain this. You can actually practice it by yourself. You can use the use send transaction. So use send transaction is very, very simple. It is used for creating and signing transactions to networks. So you remember that in our use rights contract, we have to pass in the function name. Either for using when you want to use a use rights contract, it necessarily does not have to be that you want to transfer it. It could be anything. It could be allowance or anything. But with this use send transaction, it is specifically for transaction. So let's say I want to send Ethereum on Sepolia. Sepolia is a testnet. Remember I said Sepolia is a testnet. You have to just follow the documentation. You call the send transaction from use send transaction and you pass the value of Ether. Now you might ask that, how do I now get money to send because I do not have real money, right? You want to use Sepolia because it's a testnet. To do that, you can easily just search for Sepolia Alchemy. I use Alchemy personally. You can just search for Alchemy Sepolia ETH faucet on Google. Then once you hit enter, you're going to see the site. It might tell you to create an account. You put in the address that you want to receive the testnet money. Then you can now try to use the USEND transaction personally. That's a personal assignment I want to give to you. Try to send Ether to another wallet address using the USEND transaction. So this is to send Ether. This is specifically for transaction. Why the use rights contract is used to call any right function that exists on a contract. So with this, I want to welcome you to the world of Web3 and it was nice having you here. Bye bye.